The first one is to find the rectangular coordinates for each point given the polar coordinates,
Okay, good.
and then round to the nearest hundredth if necessary.
Okay.
So the first one is 2 comma pi over 4.
Okay. The three key conversions are x equals r cosine of theta and y equals r sine of theta.
Mm-hmm.
In fact, we can use nothing but this on this problem.
Yeah.
All right, so what's x going to be equal to?
R cosine of theta, so we'll take 2, so x is equal to 2 cosine of pi over 4.
Which is?
Cosine at pi over 4 is root 2 over 2. So 2 root 2 over 2.
So
and so it'll just be root 2.
The x coordinate is just root 2. Because remember we had to multiply it by r.
Uh-huh.
Okay.
Oh, I see.
What's the y coordinate?
2 sine, isn't the y coordinate just the same thing?
Uh-huh. Just wanted to see how long it was going to take you to get there.
Yeah. I had to look at that and I was like, wait a second.
All right. Most of these, those are the only conversions you're going to need, those two. Okay?
Okay.
Sometimes you might need the x squared plus y squared equals r squared, but most of the time those two will be sufficient. So what's the next one?
The next one is 5 comma 240 degrees.
Okay. So
this is where I get tripped up because I don't have my degrees as solid as I have my radians.
Well, okay. So what's the general for x?
R cosine of theta.
Okay.
So it would be 5 cosine of 240 degrees.
What's the reference angle for 240 degrees?
240 degrees. Pi over 6, so 60 degrees?
Uh-huh. What's cosine of 60?
Cosine of 60 is 1/2.
Is it plus or minus in this quadrant?
It'd be negative because it's going backwards. Oh, okay. Huh.
So our x coordinate is minus 5/2. What's the y coordinate?
The y coordinate is 5 sine of 240, and it would be also negative, so it would be 5 times root 3 over 2.
That's it.
I just had to think about it.
Yeah, no, that's going to be your answer. There's your x and y coordinates.
Oh, really?
Uh-huh.
Okay.
In other words, yeah, there's no further reduction that can be done.
Okay.
Or rationalization that's needed, but I don't think your teacher makes you rationalize it, if I remember right.
No, yeah.
I'm having that discussion with a lot of trig students this week.
Having to rationalize them?
Finding out that about 90% of the teachers want you to rationalize it.
Huh.
They don't go.
Yeah,
they don't go for this no rationalization stuff. Even
Mm-hmm.
Even though it makes the most sense is to not rationalize.
I know, and the funny part is about it, when I took my ACT and SAT, they didn't like anywhere specify that you have to rationalize your answers, right. And you got the same amount of credit rationalized or non-rationalized.
Well, good for them. Good for them, yeah. Usually that's not going to be a factor because you're dealing with multiple choice. But if it was a grid answer.
Yeah, the bubbling.
Well, yeah, then it would, you could put it in either way. Yeah, either way, it's the same number. In other words, that number, if you put it into a calculator, is exactly the same as that number.
Mm-hmm.
Like I've said before, I'm not sure why we have this convention to rationalize denominators. The only thing I can possibly think of is that when you're dividing, you're splitting something up into a discrete amount. And how do you split something up into square root of 2 pieces? That's impossible to do. You could split something up into 3 pieces or 5 pieces, or you could even divide by 4/3. But how do you divide by an irrational number? And I think that's the thinking behind it.
Yeah. Yep, yep.
What else we got?
The next one is -2, 4 pi over 3.
Okay. What's the x-coordinate going to be?
-2 cosine of 4 pi over 3. So it'd be -2 times -√2/2.
What's the reference angle for cosine of 4 pi over 3?
Oh, pi over 3.
Okay.
So it would be the cosine -1/2.
So what's the answer?
-1.
+1. I got a -2 times a negative.
Okay.
So x is a +1. You're correct that the cosine of 4 pi over 3 is -1/2 because it's in the third quadrant.
Mm-hmm.
So, but you've got to bring in, again,
Yeah, the negative.
you don't want to drop a negative ever.
Mm-hmm.
It's a pretty easy thing to do also. So what's the y-coordinate going to be?
-2 times -√3/2. So that just becomes √3.
Yep.
Cool. Okay, and so that's the last of like going from polar coordinates.
I'm just going to say, let's go the other way.
Yeah, so now it's going to have us go from rectangular, is it rectangular? Yeah, rectangular coordinates.
Rectangular to polar. Okay, what are the rectangular ones?
Okay, so the first rectangular one is 7, 10.
Okay. If x is equal to r cosine of theta, all right, there's one other conversion here that's really important. And that's figuring out what theta is.
Isn't it tan theta equals y over x?
Yeah, it's actually not quite that easy. In other words, it's the inverse tan of y over x if, and this is the key, and this is a little tricky, if x is greater than 0. If x is less than 0, then it's the inverse tan of y over x plus pi. If x is less than 0. I think I got that backwards. Hold on a second. We can figure out.
Okay.
In this case, we know that I'm not adding pi to this thing. Because if I draw a picture of where this point is, it's right there. So,
yeah.
7, 10. So I know I'm looking at a first quadrant angle.
Mm-hmm.
So what is the inverse tan of 10 over 7?
The inverse tan of 10 divided by 7 is 96.96.
give it to me in degrees.
Oh, sorry, yeah. Degrees. 55.
So I've solved for theta.
Okay.
And now r, in other words, I know that x is equal to r times the cosine of 55 degrees. There's only one unknown there. It's r. So r is going to be 7 divided by cosine of 55. What is that?
7 divided by cosine. 12.2.
Okay, now let's talk about this rule on figuring out theta.
Okay.
This part right here. It's a strange rule. It's rare that you see a rule like this.
Mm-hmm.
It's not dependent on what y over x is. It's dependent only what x is. If x is greater than 0, then you get this, y over x. But if x
Okay.
is negative, it's y over, the inverse tan of y over x plus pi, and that's regardless of what y is. In other words, if both y and x are negative, well, I'm in the third quadrant, right?
Uh-huh.
That's why I got to add pi to it. Because if both of them are negative, I'm going to get a first quadrant answer.
Yeah.
Because
Oh, I see.
I'm going to have the inverse tan of a positive number. And that's going to give me
Okay.
a first quadrant angle. But I can tell from where this is that it's in third quadrant. If that's minus 7, minus 10, then because the x is negative, then I got to add pi to my answer. So my answer wouldn't be 55. It would be 55 plus 180. If I'm dealing with a minus 7 and a minus 10.
Okay. So I have a question. I understand why you'd add pi if you had -7 and -10, because that throws you in the first quadrant, and then you add pi to get back to the third quadrant. But why would you add pi if you're in if only x is negative? Because I'm confused on why.
Now let me think how.
Because I'm just wondering, like, where would that put you back?
If only x were negative, let's say a situation like that.
Uh-huh.
That's your angle. And that point is minus 3 comma 10. So I would be taking the inverse tan of 10 over minus 3. What kind of answer is that going to give you?
Oh, a negative answer.
Negative angle. It's a first quadrant negative angle. Right?
Yeah.
It's going to give you an answer in that fourth quadrant. So by adding pi, it gets me to the proper quadrant. In other words, it's going to give me the answer for that. Add pi, you get into the second quadrant, which is where you're supposed to be.
Oh, okay. I see how that works.
It always works. If x is negative, you add pi to your answer. If x is positive, then you just take the inverse tan of y over x.
Mm-hmm.
That gets you the right quadrant every single time.
Okay.
I
see how that works.
If y were negative and x were positive, it's going to give you that fourth quadrant, and that's where you're at. In other words, y is negative and x is positive in the fourth quadrant. So you would not be adding pi, but you wouldn't want to, because when you take the inverse tan of a negative argument, it gives you that fourth quadrant angle.
Yeah.
As a negative angle. And there's no question is, can you put a negative angle in there for theta?
Yeah, we have a couple of negative angles.
I guess you can. Yeah. In other words, I don't think there's anything wrong with putting a negative angle there. It just means you go clockwise instead of counterclockwise when you're getting plotted.
Yeah.
In other words, let's make sure we know what we're saying here. If I had 2 minus 30 degrees and I wanted to graph that, I'm going to go to the negative 30 degrees and I'm going to go out 2 units. So that's where I'm going to be, with that being my 30-degree angle.
Yeah.
Okay, and let's make sure that that's r theta. So x is going to be 2 times the cosine of minus 30, which is a positive number. And y is going to be 2 sine of minus 30, which is going to be a negative number. So it puts us in the right quadrant. So yeah, you can use negative thetas. But that would be the same as 2 comma 330. In other words, if I go around 330 and then go 2, I get to the same point.
Yeah.
You always want to end up on the same xy point. And polar and xy can be done on the same piece of paper. They're not different coordinate systems. That's important to understand. In other words, every one of these points, if you give it to me in polar, I can plot it in xy, and that's the same point as it is in polar. In other words, it's not like a different coordinate system.
Yeah.
It's the same coordinate system. It's just polar instead of. Oh, and I read a little bit more yesterday. You know who invented polar coordinates? Isaac.
Wasn't it astronomers?
No, it was done for astronomy purposes, but it was Isaac Newton.
Oh, wow.
Yeah, really. I mean, he
did everything.
He invented calculus. He invented, they say that the book that he wrote, Principia Mathematica,
yeah,
the most important math book in the history of mankind, and he didn't even have calculus in that. He had actually invented calculus 20 years before he wrote that book, but he was afraid to put it in the book because he didn't trust it.
Oh, man.
He did not like this notion of dividing by numbers that approached 0. It came too close to violating the first rule of math, which is do not divide by 0. And so he didn't trust it. A lot of people didn't trust it. There's a lot of famous mathematicians that spent their whole life after calculus was invented questioning its validity, whether it was really correct or not.
What is the basis of calculus, though? Or is it dividing by numbers smaller than 0, or
no,
there's nothing?
I'll give it to you in a nutshell.
Okay.
I want to find the area under that curve. I don't have any geometry way of doing it. So I'm going to break it up into rectangles, and then I'm going to add up the area of each rectangle. That's how I'm going to do it. But that's going to give me an approximation, okay? Well, the way I'm going to solve it is by I'm going to put an infinite number of rectangles in this area. In other words, I'm going to let the width of each rectangle approach 0.
Oh, I see.
The more rectangles I put inside that, the more accurate my answer is. Right now, I've only got like 10 rectangles. I got all this space. That's inaccuracy there. I got a little extra space over here. That's inaccurate. But as it turns out, if I were to put 100 rectangles in there, making the width of each one 1/10 as wide, I would have a more accurate approximation. And if I were to put 1,000 rectangles in there, I would have a really accurate approximation. But the perfect answer that's not an approximation is if I put an infinite number of rectangles in there, which is saying I'm going to let their width go to 0. So that's where you get this concept of dividing by 0.
Huh.
Or multiplying by 0. In other words, I'm going to get the area of each rectangle by multiplying its function value times the width. That gets the area of that rectangle. And I'm just going to sum them all up. Well, the summation sign is sigma, which turns into an integral sign, which is calculus. Well, sigma is calculus also. But when you sum up a bunch of things, that's what this integral sign means.
Okay.
Means you're summing up a bunch of stuff. But that's where you get the dividing by 0, is putting in so many rectangles in there that the width of each one approaches 0. It doesn't actually go to 0, it just approaches it. And that's why calculus doesn't violate the thou shalt not divide by 0.
Huh.
All right.
Okay.
What else? You got some more polar?
Yeah. The next one is, we have like 2 more of the rectangular, and then we're going to get into solving like equations.
Okay.
So the next one is 4 comma negative 12.
Okay. Let's figure out theta first. Theta equals what?
Inverse tan of negative 12 over 4.
Correct. What is that? That's negative 3. What's the inverse tan of negative 3?
Negative 71.
Notice it gives us a 4th quadrant angle. Always. So this would be negative 71 degrees. And then you just have to solve for r. In other words, I know that x equals r times cosine of 71. Well, I know what x is. It's 4. So
I take cosine of 71 divided by 4.
The other way, it's going to be 4 divided by the cosine of 71.
Oh, okay.
That's what r is going to be.
And r comes out to be 12.2. Okay.
The whole key is x. X was positive, so I didn't have to add 180 degrees to that answer.
The next one's kind of tricky.
Okay.
So it is a comma 3a.
Not going to be tricky at all.
But then a has to be above 0.
Okay. Tell me what the first thing I want to do is.
Take the inverse tangent of a over 3a. Or no, put something in for a.
Oh, no, you were right. I want to solve for theta, right?
Yeah.
Well, theta is the inverse tan of 3a over a, and they told us a was greater than 0. They told that for a reason. That means we don't have to add pi to it.
Okay.
If they would have said a is less than 0, then I would have to add 180 degrees to this answer. But the a's cancel. So again, it's the inverse tan of 3.
Oh.
What was that? The negative 3 was negative 71 degrees?
Yeah.
So this must be 71 degrees. And r could be a little tricky. R is, hold on, let's see. X equals r cosine of theta. So
could we maybe find r by using the x squared plus y squared equals r squared thing?
Maybe. Let's just see if I can get it this way. If x is a, then a is r cosine of 71, which doesn't solve for r.
That have two variables.
I can't solve for r. R is going to be this. Here's the reason I can't solve for it. It can't be fixed if I don't know what A is. In other words, A and 3A is right there, correct?
Mm-hmm.
But if A is 2, R would be one thing. If A were 12, R is going to be a much different thing.
Mm-hmm.
So R has to be a function of A. If I don't know what A is, I can't come up with a number for R.
Okay, I see how that works.
Because, yeah, if A was a big number, then R would be way out there. If A is a little number, R could be a tiny little number like that.
Mm-hmm.
So there's no way to solve for A. But that's what they're going to want to see. Maybe you want to put whatever the number for cosine of 71 degrees is, rather than put your answer as A over that.
Mm-hmm. Okay.
That's always your first step. Okay. Now, you said maybe we could solve for A using the other relationship. Well, I'm pretty sure we're not going to be able to, but let's just prove it. In other words, we've got r squared equals x squared plus y squared, which would make r squared equals a squared plus 9a squared, which means r squared equals 10a squared, which means r equals plus or minus the square root of 10 times a. And if you'd have solved for the cosine of 71 degrees, you should get something very close to that. Go ahead and solve for the cosine of 71 and divide a by that number. I'll bet you get something that's very close to square root of 10 times a.
The cosine of 71 equals 0.32, and
yeah, you're going to get that same answer. Because you're going to get a over 0.32, and that's like 3a. Well, square root of 10 is real close to 3a. So I could have solved it using either technique, and notice that neither one of them solves for r. It just gives you r as a function of a, which I can get either this way, easier maybe, than this way. Same answer though. Okay, what else?
Okay, so the next one is to identify the graph of each rectangular equation and then write the equation in polar form.
Okay.
And it says support your answer by graphing the polar form of the equation if necessary.
Okay.
So the first
graphs, or do you recognize what they are?
I think I recognize what they are.
Okay. What's the first one?
X equals -2.
Okay. We know that that is a vertical line. So, thinking. Well, let's see. X equals R. This is good. Well, let's go back for a minute. What's our first step on these always? Solve for theta.
Solve for theta.
Right? So theta equals the inverse tan of, there's no y, but it's y over minus 2 plus pi.
Mm.
Nah, my mind is drawing a blank here. X equal minus 2.
Sorry,
There,
I'm just looking at my notes to see if we did any examples of this in class too.
well, what could this be?
Oh, do we need to use
This is where we need to use that x squared plus y squared, I think.
or could it be like where we need to use like x equals r cosine theta? So instead of like having x be x, we could replace x with r cosine theta and find r.
So I've got minus 2 equals r cosine of theta.
So then we take.
Do I know theta?
Oh, yeah, I guess you don't know theta.
In other words, if I'm measuring everything from the origin, I don't know theta. Depends on what y is. There's a way to do this. Hold on, let me look in my book. Maybe I'll see an example of this problem. Some of these require clever solutions. And
I know when we did in class, we didn't do one that was like x specifically equals -2.
yeah,
We would do one where like x squared minus.
yeah, there's, no, I'm going to find one, except, God, I'm missing 3 pages from this.
Could we be possibly using identities? So what could replace cosine of theta?
Hold on. Hold on. I can't believe it. My polar chapter is gone. No, hold on. No, it's not. Where is my... Oh. This way. Just a second. I'm going to get this.
Because on these problems, our teacher would let us leave the answer as r equals 8 cosine theta. But that's going from like x minus 4 squared plus y squared equals 16, and then finding it all from there. But
Let's see, if I do... What would the polar thing look like even for that? In other words, r equals 2 is
I think
a circle.
I think in this one our answer should end in, so if I take 26, -2 equals r cosine theta, r equals
Yes.
divided by cosine.
Okay, there, that's all we need. Yeah.
Yeah.
In other words, r equals minus
-2
2 over cosine theta, which you don't also want to leave a trig function in a denominator. That's minus 2 secant theta.
Yeah.
So that's the answer. R equals minus 2 secant theta. I kept trying to solve for theta, and there's no solving for theta. What we're trying to do is come up with a polar equation. And
yeah,
R
that's what
equals a function of theta is a polar equation. So that's all we have to do on that. It's not as hard as I was making it seem. So one thing to learn from that is the first step when you're converting to polar equations is not necessarily to solve for theta. It's to use those other relationships and end up with r as a function of theta.
Yeah.
And that's pretty easy to do. All right. What's the next one?
Y equals -3.
Okay. Well, now that we know how to do it, tell me.
-3 equals r sine of theta. -3, or whoops, r equals -3 over sine of theta. So r equals -3 cosecant.
There you go. Now, some of these can be a little tricky. For instance, I think I mentioned this before to you. If I have something like this, if I'm going from polar to rectilinear, this requires a bit of creativity. And that creativity is multiplying both sides by r, so that r squared equals 4r cosine of theta. Now, that's equal to x. And this over here is x squared plus y squared, so I end up with this.
Oh, I remember doing these, and then you'd move the 4x over to be x squared plus y squared minus 4x.
Right, equals 0. But my thing is that I've taken a polar equation and changed it into a rectangular equation, or rectangular. But it wasn't that easy to do. In other words, if you weren't familiar with this technique, that might be hard. If I didn't know that I had to multiply both sides by r, what else could I do here? Let's see. I could do, no, that'd be hard. I
don't know really what you could do.
Well,
I only thought you make a place.
X over cosine of theta. So I know that's what r is. And if that's equal to 4 cosine of theta, now I'd have to multiply. In other words, I don't get much place. I multiply both sides by that. Now I'm looking at that, and I still haven't got it in terms of x and y.
Yeah.
So going from polar to rectangular can be a little tricky if you don't know that one step, where when you have something like this, you have to multiply both things by r. And the reason you want to do it is because you want to get r cosine of theta. In other words, if I can get an r cosine of theta, I can substitute x for it. Okay? But there's no way to get r cosine of theta. I could divide both sides by r. That doesn't give it to me. But I can multiply both sides by r. And that does give it to me. All right.
Okay.
What else do you got?
The next one is...
These are a piece of cake compared to vectors.
Yeah.
I have one for you that's very interesting. Only because it's one of the few times you'll ever see this. Here is my rectangular coordinates. Tell me what my polar coordinates are.
0, 2. Theta. Oh. What do you do here? Because you can't divide by 0.
Ah, yes you can. It's the only time in math you can divide by 0. When you're taking, well, think about what inverse tan means. If I'm taking the inverse tan of infinity, which is what this is, that's 90 degrees.
Oh, I get it.
Where is that point? That point is right there.
Straight up. Yeah.
Okay, so the polar is, there's the ray, but there's the point. But in order to get that point, I did actually have to take the inverse tan of infinity to come up with 90 degrees. Remember that tan is not defined at 90 or minus 90. This means not defined. So you can go backwards to realize that this has to be 90 degrees. That's equal to 90 degrees. And it is essentially division by 0.
Yeah. Okay. What about if you had 2, 0, and you're supposed to try to divide 0? Would you get 180?
0 by 0?
If you had the coordinates 2, 0.
Oh, 2, 0. No, then that would just be the inverse tan of 0 divided by 2. And that's 0. In other words, the inverse tan of 0 is 0.
Okay. Is there any way to get 180 out of that? Yeah, -2? Yes.
Well, that's a good question. Because that rule about adding pi, I'm not sure how that applies when x
Oh,
is 0. In other words, x is neither positive nor negative. So what do you get? This is a good question. Put this in your calculator. Do
okay.
inverse tan of 2 divided by 0. Let's see if it coughs. It shouldn't. It should give you a 90-degree answer.
Nope. It says you can't divide by 0.
Really? Interesting. Even
So
with inverse tan. I'll bet I can do it on Wolfram Alpha. Let me see.
maybe in one of the newer calculators or
Possibly.
yeah, Wolfram Alpha.
Let me see. Well, gosh, let's see. I need arc tan of 2 divided by 0. Result says undefined, but it isn't undefined. It's 90 degrees.
Huh.
Well, that's interesting. And here, I just want to draw the tangent curve for you, just so you understand why I think I'm going crazy here. We've got a vertical asymptote at minus 90 degrees, or minus pi over 2.
Yeah.
Vertical asymptote at pi over 2.
Uh-huh.
And the tan curve goes from negative infinity through 0 to positive infinity. So we take tangents of angles to get ratios, and we take inverse tangents of ratios to get angles. So what's wrong with taking the inverse tan of this ratio? That does give us the angle pi over 2. Or if I had negative 2 divided by 0, that would give me the answer minus pi over 2.
I'm confused on how that gives the answer, though.
What's that?
I'm confused on how that gives pi over 2, though. Because is 0 is pi over 2?
Okay, this is what's undefined, is tangent of pi over 2. That's undefined.
Okay.
Undefined is kind of another way of saying infinity.
Okay.
Okay, you can see from the curve that we're headed towards positive infinity.
Yeah.
So if I was doing a limit problem, the limit of tangent of x as x goes to pi over 2, that's infinity. Okay? You can see from the curve that that would be infinity. So
yeah.
Inverse tan of infinity should be pi over 2. And this is infinity, or negative infinity, when you divide by 0. So I'm not quite sure why my Wolfram Alpha or your calculator doesn't like it, but I'm very sure that you can have problems like this with converting rectangular to, in other words, it's very simple. If I give you an xy coordinate of 0, 2, that's certainly a point, right?
Well, yeah, it even gives me one on my homework where it's 0, negative 173.
Okay, well, now hold on. That's a polar coordinate there. I'm talking about an xy coordinate where x is 0. Because when we convert xy to polar, the very first thing we do is figure out theta. And
no, this is a rectangular coordinate.
What's that?
This is a rectangular coordinate asking for the polar coordinate.
So if I want the polar coordinate, I've got to solve for theta. And theta is the inverse tan of y over x. So it's the inverse tan of 2 over 0. And that is 90 degrees. I can tell from my point. That's a 90-degree angle from the origin. In other words, the polar coordinates on that point are going to be 2, pi over 2.
So even if it was 173 per se, it would still come out to a 90-degree angle, right?
Yeah, if it was 173 divided by 0,
Yeah.
yeah, that'd be 90 degree. But I think the 173 you're reading is an angle, is it not?
No, it's a rectangular coordinate.
Okay.
It's actually it's a negative 170 degree.
Oh,
73.
but it's not degrees.
No, it's not degrees.
Okay, it's just a negative 173. Yeah,
Mm.
that actually is going to be a minus 90 degree angle. In other words,
Yeah.
if you plot that x coordinate, your minus 173 is going to be way down there, right?
Yeah.
That's a minus 90 degree angle.
So that'd be 3 pi over 2.
Or minus 90, yeah.
Or minus 90, yeah.
Either one, or minus pi over 2, yeah.
Hmm.
So you can always tell what theta has to be by plotting the coordinate and figuring out the angle that you would have to go to get to that point.
Okay.
But calculators are going to be a little scary. If it won't give you a calculator answer, then this is what you're going to have to do whenever they give you an x of 0. Actually, here's what you do. If x is 0, it's a 90 degree angle. If x is 0 and y is negative, it's a minus 90 degree angle.
Yeah.
In other words, it's either plus or minus 90 depending on what y is.
Uh-huh.
Yeah, no, this is an interesting problem, and like I said, this is the only thing I've ever seen in math where you can actually divide by 0 and it kind of has meaning. Not kind of, it does have meaning.
Yeah, like it's a definitive answer.
Right. In other words, the inverse tan of something divided by 0 is 90 degrees. Unless it's a negative something divided by 0, and then it's minus 90 degrees. So there should be a rule not just concerning whether x is positive or negative, but if x is 0, then whether y is positive or negative. You know what I mean?
Mm-hmm.
In other words, their rule is theta is inverse tan of y over x plus pi if x is less than 0. Well, they also need a rule that if x is equal to 0 and y is less than 0, then it's minus 90, and if x is equal to 0 and y is greater than 0, then it's plus 90. Interestingly enough, when I look in my pre-calc book and it gives me the rule for a tangent of theta, it doesn't say anything about that adding pi.
That's kind of interesting.
Well, it is, because I got another book that's exactly the way they do it. No, this book that I'm looking at now does not add pi, but it gets to the right angle regardless by graphing it and knowing what quadrant you're in.
Oh, I see.
But it doesn't give the formula as inverse tan of y over x plus pi of x is less than 0. And I got another book that gives it this exact way. In other words, if x is greater than 0, it's just inverse tan of y over x, but if x is less than 0, it's inverse tan of y over x plus pi.
I guess it's just kind of like getting it through that one step of graphing and knowing your, like, quadrant.
Right. And as long as you know how to graph the x and y, you know which quadrant you're in. Or you know you're a quadrangle. Angle, a quadrangle angle, which is multiples of 90. Okay. You got any others? We got 5 minutes. I do have a 9 o'clock tonight. Somebody.
Okay, this will be the last one then.
Okay.
So it is x minus 2 squared plus y squared equals 4.
Okay. I can see that that is a circle whose center is at 2, 0, right?
Yeah.
And has a radius. So the center is at 2, 0, and it has a radius of 2. So that's what we're looking at. Now how to describe that by polar. Okay, I can do that. First of all, let's expand that. So you get x squared minus 4x plus 4 plus y squared equals 4. Well, the 4's cancel. And now, wherever I see x, I'm going to write r cosine of theta. So that becomes, is that what I want to write? No, hold on. Easier way. I got an x squared plus y squared. I'm just going to substitute r squared for that. So
Okay.
r squared minus 4x equals 0. And now r squared minus 4 and x is r cosine of theta equals 0. And
Now you move the negative 4r cosine over to the other side. Oh, maybe not.
well, I was going to factor out an r. Ooh, what do I do from here? Let me think about this just a minute. In other words, I want my answer to be r equals something.
Yeah.
Well, I can factor, can't I?
Yeah, I think factoring out an r would
Yeah,
be the best way
factor
to go.
works. What was I thinking? This is just like an algebra problem. I'm going to factor out an r. I get r minus 4 cosine of theta equals 0. So either r equals 0 or r equals 4 cosine of theta. So there is the equation of that circle that we're looking at.
Yeah.
The r equals 0 is like an extraneous solution. It's basically a single point. If you think about what r is the length of the ray. So if r equals 0, that's a point right there.
But I thought r was also the radius, and we know the radius. So my question is, could you
R is not
implement...
the radius. R is not necessarily the radius.
Okay.
R is the magnitude of the line that goes from the origin. But once you start having things like circles that aren't at the origin, in other words, if you put that circle at the origin, then the equation of it is r equals 2, right?
Yeah. Yeah.
But if the circle's not at the origin, like this one, then I've got to go through this process over here and solve for r.
Okay.
Solve it just like a quadratic. You factor it, and then either r is 0 or that's 0. And once you set that equal to 0, it gives you the equation you're looking for.
Okay. Okay.
Okay?
Cool.
All right, Nick, I'm going to let you go. That was more fun than the other night.
Yeah.
Talking
Definitely.
about vectors, parametric. I'm getting better at them. I used to have a mental blank that, boy, you just mentioned the word vector and my mind would go blank. But having to tutor them every year, at least for a couple of weeks every year, I'm better at them. So it's not so bad.
Yeah.
But it's better
My
if
vector.
problems. It's hard for me to conceptually give a lesson of those 3 subjects without specific problems to do.
My vector, will be coming up here pretty soon.
Oh, you haven't had it yet?
Yeah, we're gonna have ours at I think the last one or the second to last one.
Oh, so you're going in the order of polar and then vector and then parametric equations.
Yeah, I think so.
Yeah, yeah, those are fun too. Actually, they are compared to vectors. Vectors are the one, that's the only thing that really, there's something about vectors that bothers me. I'm not quite sure what it is, but I can still help.
Okay.
All right, Nick. Have a good night.
Julio. Thank you, Mr. Cohen. Have a good night.
You too. Bye-bye.